Hello students, this is video 7.8. Your objective is I can draw a locus, and there are very many types of loci that you will see soon. Your Excel skills are, hey, make sure they're done. All the ones that are supposed to be done should be done. And now you want to use that extra time because I'm not giving you new skills tonight. And remember, you can do bonus iExcel, right? Any 5 from the unit that you haven't done, or any 5 from geometry or higher, so that you can get those points you missed. Remember, it's 20% of your grade. You need every point. All right, let's go, flippers. Okay, so a locus is a set of points that satisfy a condition. And there are 5 different types of locus. All right, so let's focus on the first one. The first one is a locus of points at a fixed distance D from point E. Think about point E. So if I make point E, then there's going to be a set of points a fixed distance from point E. And you're thinking about it, you're right. It is a circle. So a circle is a locus because all those points are going to be the same distance from E. Okay? All of them are going to be our radii or radius. Let's just add that in, that this first one is a circle. Number 2, okay? The locus of points at a fixed distance D, again, from a line now, is a pair of parallel lines. So if I have a line, let's make a line, and I want a locus of points from this line, then I'm going to have 2 lines. One line above the line and one line below the line. And those lines are going to be parallel lines, and they're going to be equal distance. So from this line, they're going to be the same distance. So if this was D, this would also be D. Number 3, the locus of points equal distance from 2 points. Let's make 2 points. There they are, points P and Q. Okay, is going to be the perpendicular bisector of the line segment determined by the 2 points. So basically what that means is take these 2 points, make a segment to connect them. All right, so there's a line segment. And the locus of points is going to be this line segment here, or line, which is a perpendicular bisector, thus this is a right angle. So every single point on this line is the locus of points for these 2 points. So this one actually is a line. So this locus is a line. And I actually want to back up a second because we didn't mark the second one. This locus is actually 2 lines. So this one is 2 lines. This one is 1 line. And this one is 1 circle. All right. The 4th locus. All right. So the 4th locus is the locus of points equal distance from 2 parallel lines. So let's draw 2 parallel lines. 2 parallel lines, L1 and L2, is a line, which should make total sense to you. It's going to be, that's right, the line directly in between them. That, again, they will be equal distance from here to this line and equal distance to that line as well. So this is actually 1 line as well. And last but not least, the locus of points equal distance from 2 intersecting lines. So let's draw 2 intersecting lines. Are my 2 intersecting lines, L3 and L4, and you can call them X and Y if you want to, is going to be a pair of bisectors that bisect the angles formed by these 2 lines. What would that look like? You guessed it. Here are those 2 lines. Okay, so these lines are the locus of points that are equal distance from these 2 intersecting lines, and they do bisect these angles here. Okay, so again, our answer for this one is 2 lines. All right, so let's look at some examples. In the first example, it says, what is the equation of the locus of points 4 units from the origin? So the locus of points here would really be very cool. And we have to think about the origin. The origin is really important. And the origin here is going to be 0, 0. So if you can imagine a circle at 0, 0, that would be x plus 0 squared plus y plus 0 squared equals r squared, right? And r here is 4, so we're going to have x squared, right? The 0 goes away because it doesn't do anything, plus y squared equals 16. And you're probably wondering, how did I know it was circle right away? And that's because it asked for, all it gave me was 4 units from a point. So this is locus from a point, and that has to be a circle. All right, here's question number 2. It says, so the next question is, what is the equation of a locus of points 5 units away from the y-axis? So we're talking about the y-axis, and we're trying to figure out, we have a line. What's the locus for a line? The locus for a line is 2 lines. And that would have to be, since it's 5 units away, 5 this direction, 5 this direction. So the equation would actually be the 2 lines here. This is the line x equals 5. And this is the line x equals negative 5. So here's question number 3. It says, what is the equation of the locus of points equidistant from the x-axis and the y-axis? So this is actually asking you about a locus of points of 2 lines. So since that is the case, we have 2 things to think about. Are these 2 lines intersecting? Well, the x-axis and the y-axis do intersect. So that means we're looking for the locus of lines that intersect. Therefore, we are talking about 2 lines. And just as we kind of looked at before, the x-axis and the y-axis are here. And those 2 lines that would be the locuses of those, the loci, would be the line y equals x and the line y equals negative x. Last but not least, what is the equation of the locus of points equidistant from the lines y equals negative 2 and y equals negative 3? So what you have to do here is you probably should graph these 2 lines. But you're looking for the locus of 2 lines, and when you graph them, you're going to notice right away, oh, these 2 lines do not intersect. So I'm probably looking for a locus that is 1 line. So here is y equals negative 2. And there it is, about there. And here is y equals 3. So what would be the locus of points that satisfies the condition being equidistant from these 2 lines? And the answer is, that's right. It said y equals 1/2. Okay? Because it is equidistant from y equals 3 and y equals negative 2. Last but not least, here is your secret hot question. It says, what is the equation of the locus of points equidistant from the points 4, 2, and negative 2, 2? Quick hint here. Graph these points. Graph these points. It will help you figure out how to do this problem. And remember, for IXL tonight,
no new IXL, only bonus IXL.
see you in class.